System of linear equations with three variables. Consider the system of linear equations with three unknown x, y, and z. In mathematics, basically, if there are three unknowns, you need to have three equations to solve in the simultaneous equation method. So first of all, we arrange all the three equations like this. And then from here, all the linear systems above can be written as a single matrix equation as below, with A is the matrix itself, B is all the coefficient here, B1, B2 and 3, and capital X is all the three unknowns that you want to find, X, Y, Z. Thus, the system of linear equation can be written as AX equal to B. In matrix form is like this. Solving system of linear equations. System of linear equations can be solved by two methods. The first method is by using the inverse matrix, and you have learned before by using adjoint method how to find the inverse matrix. And then the second method is by using the elimination method. Basically, it is elimination row operation method that you have learned before, but the name here specifically is Gauss-Jordan method. Alright, using the inverse matrix to solve AX equal to B. As you know before, if A is any n by n square matrix that has an inverse, which is we write it as A inverse, capital X is a variable matrix, which is all the unknowns that you want to find, or X, Y, Z. And lastly, capital B is a known matrix, both with n rows. Then the solution of matrix equations AX equals to B is given by X here is equal to A inverse, you multiply it with B. As you learned before, for multiplication between two matrices, the arrangement is important. You must always remember the inverse of the matrix comes first, and then you multiply it with the known matrix. It is not like this, yeah? It is not like this, B A inverse. It is A inverse B. So how do we get with that equation? Here is the proof. Okay. Here is the original equation, AX equals to B, which is 3 by 3 square matrix. Now you multiply both sides of the equation with A inverse to balance the equation, and then you will have on your left A inverse A X is equal to A inverse B. Then you have learned also before, A inverse, when you multiply it with A, you will get identity matrix. Then identity matrix, when you multiply it with the matrix, you will get the matrix itself. So that's why X is equals to A inverse B. That is the first step. The second step, your job here is to find the A inverse. To find the A inverse here is by using the adjoint method that you have learned before. The equation given is 4x minus 3y equals to 2 and x plus 2y equals to 1. So the first step is we need to write the equation in a single matrix form. 4, negative 3, 1 and 2. Here is a matrix of x and y, and then equal to 2 and 1. Here is in a matrix form A x equal to B, as you have learned before. Then you have learned also to find the solution. X is equal to A inverse times with B. So for the next step is we need to find the A inverse. To find the A inverse by using adjoint method, you have learned before this. So A is equal to 4, negative 3, 1 and 2. By using adjoint method, A inverse will be 1 over AD minus BC times it with D, negative B, negative C and A. So for this specific matrix, A inverse will be 1 over 4 times 2 minus 3 times 1, and then multiply it with 2, 3, negative 1 and 4. Do you understand? Okay, now we proceed to solve the calculation. So here you will get 1 over 8 plus 3, 2, 3, negative 1 and 4, which is 1 over 11, 2, 3, negative 1 and 4. Then lastly, don't forget to multiply all the elements in the matrix with the 1 over determinant. So you will get the final matrix of A inverse is 2 over 11, 3 over 11, negative 1 over 11 and 4 over 11. That's how you solve for finding the A inverse. Then because the question asks you to find the value of x and y, so we proceed. Since x is equal to A inverse, multiply it with B. So A inverse we use the one that you get before already. So 2 over 11, 3 over 11, negative 1 over 11 and 4 over 11. Matrix of B is 2 and 1. By using your knowledge that you have learned before, multiplication of two matrices, you will get the final answer here is 7 over 11 and 2 over 11. But don't stop here. You need to write the conclusion. Okay, so the value of x here is 7 over 11, and the value of y here is 2 over 11. That's how you solve the system of equations by using adjoint method. Now we go to the 3 times 3 matrix. So solve the following system of equations by using adjoint method. First step is you write the equation into the matrix form: 3, 1, 2, 3, 2, 2, and 1, 0, 1. And then x, y, z. The matrix B will be 11, 10, and 5. Here is the matrix A, matrix X, and matrix B. Then, for the second step, you need to find the A inverse by using adjoint method, which is 1 over modulus A adjoint of A. What is adjoint A? Adjoint A is the matrix of cofactor of A that we transpose. So first we find the modulus A, which is the determinant of A, by using the third row, because there is 0 there to make your work easy here. Okay, so by using third row, we get plus 1, 1, 2, 2, 2, minus 0, 3, 2, 3, 2, and then plus 1, 3, 1, 3, 2. Then you proceed with 1, 2 minus 4, minus 0, 6, minus 6, which is 0 also, plus 1, 6 minus 3. Then you calculate, you will get the value is 1. So the determinant of A is 1. Then one more thing that you need to find is the cofactor of matrix A. So what is the matrix of cofactor of A? We continue with adjoint. Adjoint of A is here the transpose of this matrix. So what are the matrix here? The value of the elements 2, 2, 0, 1. Here 3, 2, 1, 1. 3, 2, 1, 0. 1, 2, 0, 1. 3, 2, 1, 1. 3, 1, 1, 0. Lastly, 1, 2, 2, 2. 3, 2, 3, 2. 3, 1, 3, 2. Is that everything? No, not enough yet. Don't forget, you are doing the matrix of cofactor, not minor. So cofactor, don't forget all the symbol here. Understand? Then we proceed, we calculate. You will have two, negative 1, negative 2, negative 1, 1, 1, negative 2, 0, 3. So what is the transpose of these? It is 2, negative 1, negative 2, negative 1, 1, 1, and negative 2, 0, 3. Understand? Then you need to find the A inverse. As you know, by using adjoint method, A inverse is 1 over the determinant of A. You times it with adjoint A. So 1 over 1 times it with 2, negative 1, negative 2. Negative 1, 1, 0. Negative 2, 1, 3. Then you will have the final solution. 2, negative 1, negative 2, negative 1, 1, 0, and negative 2, 1, 3. Understand? Now, since the question didn't ask for A inverse, the question asked for X, Y, Z, you need to continue your solution with, as you know, X is equal to A inverse B. So A inverse 2, negative 1, negative 2, negative 1, 1, 0, and negative 2, 1, and 3. Times it with B. B is 11, 10, and 5. By using your knowledge of multiplying two matrices, you will get the final answer here: 2, negative 1, and 3. Then don't forget the conclusion. So here X will be 2, the value of Y will be negative 1, and the value of Z is 3. That's how you solve system of linear equation for 3 unknowns. Do you understand, everyone? Alright, for example 3, they give already a matrix A, which is 3 times 3 matrix, 1, 2, 3, negative 1, 0, 4, and 0, 2, 2. The first equation, they ask for the determinant of matrix A. So, what is the determinant of matrix A? The determinant will be here by using the first column. The determinant will be 0, 4, 2, 2, plus 1, and then minus 1, 2, 3, 2, 2, and then plus 0, 2, 3, 0, 4. Okay, and then you solve it, you will get 1, 0 minus 8, plus 1, 4 minus 6, and plus 0, 8 minus 0. Then you calculate, you will get the determinant will be negative 10. Then the question asks for the cofactor of matrix A. The cofactor of matrix A is, or adjoint of A. plus 0, 4, 2, 2, negative 1, 4, 0, 2, plus negative 1, 0, 0, 2. For the second row, negative 2, 3, 2, 2, plus 1, 3, 0, 2, and negative 1, 2, 0, 2. And for the third row, plus 2, 3, 0, 4, minus 1, 3, negative 1, 4, and plus 1, 2, negative 1, 0. Okay, and then you solve, you calculate everything, you will get negative 8, 2, negative 2, 2, 2, negative 2, and 8, negative 7, 2. Transpose. So the transpose of this matrix is negative 8, 2, 8, 2, 2, negative 7, and negative 2, negative 2. Understand? Okay, and then they ask for number 3, hence find A inverse by using adjoint method. You have already the determinant and the cofactor transpose. So A inverse is 1 over determinant of A adjoint of A is equal to 1 over negative 10 times negative 8 to 8, 2 to negative 7, negative 2, negative 2, 2. Then don't forget, you need to multiply each element with the determinant. So the final answer for A inverse 4 over 5, negative 1 over 5, negative 4 over 5. And then for the second row, negative 1 over 5, negative 1 over 5, and 7 over 10. And for the last row, 1 over 5, and 1 over 5, and negative 1 over 5. Understand? Right. And for the question B, you read the question carefully. A company produces 3 grades of mangoes X, Y, and Z. The total profit for 1 kg grade X, 2 kg grade Y, and 3 kg grade Z mangoes is Rm20. The profit for 4 kg grade Z is equal to the profit for 1 kg grade X mangoes. The total profit for 2 kg grade Y and 2 kg grade Z mangoes is Rn10. So the first question, obtain a system of linear equation. So first you need to know that you let X is the profit of mangoes grade X. Y is the profit of mangoes grade Y, and Z is the profit of mangoes grade Z. and the equations that you will find will be x plus 2y plus 3z equal to 20. Then 4z is equal to x. You rearrange, you will get negative x plus 4z equal to 0. Lastly, 2y plus 2z is equal to 10. Here are the three equations. Then for part 2, okay, you transform the equation into matrix equation. You will get 1, 2, 3, negative 1, 0 and 4, 0, 2 and 2. Here is x, y, z. Lastly, here will be negative 20, 0 and 10. A, x, b. And for part 3, since x is equal to A inverse B, by using adjoint method, you have find already the inverse of this matrix in the question part A. So you just take the answer A inverse 4 over 5, negative 1 over 5, negative 4 over 5. Negative 1 over 5, negative 1 over 5, 7 over 10. 1 over 5, 1 over 5, and negative 1 over 5. And then the B is 20, 0, and 10. Again, by using the knowledge of multiplication of two matrices, you will get the answer will be negative 8, 3, and 2. So x will be 8, y will be 3, and z will be 2. I'm sorry, there is a correction here. There is no negative here, yeah? Okay, just a positive 8. Okay. Then for the conclusion, the profit of mangoes grade X is RM8. The profit of mangoes grade Y is RM3. And lastly, the profit of mangoes grade Z is RM2. Hence, there is the solution. Do you understand?